Wow! Nothing like coming back from vacation to a warm cup of coffee and the smell of fresh code. I miss teaching, to be honest.
Same here. I thought I'd enjoy the break more, but I ended up missing JavaScript. I love it. Of course, like many people, only when everything works without crashes and errors.
I've been busy with work. Lots of calls and Zoom meetings today. But now I'm free to discuss the next topic in the most understandable language. How are you, Harry?
You know, James, I'm always up for an interesting conversation. I love our conversations when we break down complex topics so simply. Everything immediately falls into place in my head. I'm ready.
That's the spirit. So, before we jump into heavy logic, let's talk about something that confuses even experienced coders.
Let me guess. Something about objects.
Exactly. Today's topic is mutation versus immutability. Sounds intense, right?
Yeah. Sounds like a superhero movie title.
Well, kind of, but first, do you remember what an object is in JavaScript?
Sure. It's like a little storage unit. You create it with curly brackets, and you store key value pairs in it.
Right. So imagine this. You create an object called user. You say, const user equals curly bracket, name colon in quotes Harry, then curly bracket closes.
Got it. So user has a name, and the name is Harry.
Exactly. Now, if you do this, const copy equals user. You're not copying the content. You're just making another label that points to the same box.
So they're both using the same storage unit?
That's right. Now imagine you say, copy.name equals in quotes James.
Oh. So user's name changes too?
Boom. That's called mutation. You didn't touch the original directly, but changing the copy also changed the original because there are two labels pointing to the same object.
That's sneaky. So even if I don't mean to, I could mess up the original object.
Exactly. And in big apps, this can lead to serious bugs. Imagine two people working on the same document. One makes a change, the other didn't expect it. Chaos.
So what do we do?
We use immutability. It means don't change the original. Make a copy, then edit the copy.
Like making a photocopy of a form and filling in the copy?
Perfect metaphor. And in JavaScript, we have a great tool for this, the spread operator.
Sounds fancy.
It is, and useful. It's like saying, take all the stuff from this object, and then overwrite whatever you want.
So the original stays untouched?
Yes, and that's how we keep data clean and safe from accidental changes.
Nice. Is it the same with arrays?
Oh yes, arrays can mutate too. We'll look at that in a moment.
Yeah, I still have some questions about that. It's a lot clearer now, though.
So, picking up where we left off, remember how we talk about objects mutating? Well, guess what? Arrays can do the same thing.
Oh no, I was just getting used to objects. And now arrays can misbehave too.
Yeah, I know. Think of arrays like shelves in a library. You place books on them, in order, one by one. Those books can be numbers, strings, whatever. Let's say you create a shelf with some numbers. You type const numbers equals square brackets with 1, 2, 3.
So I've got a shelf labeled numbers, and it holds 3 books.
Exactly. Now, if you write const new numbers equals numbers, you're not building a new shelf. You're just putting a second label on the exact same one.
Wait, so both names point to the same shelf?
Bingo. And here's the twist. If you grab book number 2 and replace it with 99 in new numbers, you look back at numbers and it's changed too.
So that tiny change affects both? That's scary.
It's called mutation. You didn't mean to mess with the original, but you did because both variables share the same memory.
It's like I borrowed a friend's notes and doodled in them, and now they're ruined.
Perfect metaphor. To avoid this, we copy the array. And we use a clever trick called the spread operator.
Ah yes, the magical 3 dots.
Exactly. You type const new array equals square bracket, 3 dots, numbers, then close the bracket. Now you've made a new shelf that looks the same, but lives in its own space.
So when I update new array, it's like editing a copy, not the original.
Exactly. You can add, remove, or replace items without worrying about corrupting your base data.
Phew, that's a relief. But is this just theory? Or does it really matter?
Oh, it matters, especially if you're using frameworks like React.
Oh, I just started learning React.
Then this is perfect timing. React relies on detecting changes. If you mutate state directly, React might not notice, and your UI won't update properly. It leads to bugs that are nearly impossible to trace.
So mutation confuses the system?
Exactly. React compares before and after, and if the reference hasn't changed, it thinks nothing happened, even if the content changed.
Sneaky. So the rule is, always copy first, then make changes?
That's the safest way. Of course, in small scripts, it might not be a big deal, but in serious projects, mutation causes chaos.
I probably broke so many things without knowing.
We all have. It's one of those invisible traps that beginners walk into.
So this mutation problem only applies to arrays and objects?
Great question. It applies to all reference types, arrays, objects, and functions.
Wait, functions too?
Yep, anything that's not a primitive shares memory by reference. So if you pass a function or object into something else, it can affect the original.
Then what are primitive types?
Things like numbers, strings, booleans, null, undefined, and symbols. They don't share memory. When you assign one to a new variable, it makes a copy, not a link.
So if I say const A equals 5, then const B equals A, changing B doesn't touch A?
Exactly. They're like photocopies. Each variable holds its own version.
While reference types are like two people scribbling in the same notebook.
That's a perfect image. With primitives, safe and sound. With references, better be careful or it all gets messy.
Wow. This clears up so much confusion. I finally feel like I'm understanding memory.
You're doing great. And next, we'll dig into how even functions can sneakily cause mutation.
Oh boy. This topic keeps getting deeper. Bring it on.
So, Harry, now that you're clear on arrays and reference types, let's talk about when mutation hides in places you don't expect.
Hides. Like stealth bugs.
Exactly. One common place? Functions. Let's say you pass an object into a function and expect the original to stay untouched.
Let me guess. If the function edits the object, the original changes too?
Bingo! Because it's still the same reference. So any edits inside the function go straight to the source.
That's dangerous. I might think I'm working with a copy, but I'm not.
Right. Imagine giving someone your journal or textbook to spell check, and they rewrite your entire story or rip out pages.
Okay, ouch. So how do I protect my data inside functions?
You make a copy first, usually with the spread operator or another method like object.assign. Then the function works with the copy, not the original.
Makes sense. But doesn't that slow things down?
A bit, yes, but it saves hours of debugging later. Most developers prefer predictable behavior over tiny performance gains.
So in team projects, immutability helps keep everyone sane?
Exactly. Without immutability, team code becomes a game of who touched it last.
I can already see the horror stories.
Here's one. Imagine a shared object being updated by two components at once. The app crashes and no one knows why.
Because both were unintentionally editing the same object.
Yes, that's why frameworks like Redux enforce immutability rules. They make copies of state before updating it. So changes are always intentional and controlled.
Okay, that makes it clearer. But is immutability always necessary?
Good question. If your code is simple or doesn't involve shared state, mutation might be fine. But once your app grows or involves other developers, immutability becomes essential.
So it's like using safety gear. Not always needed, but really important when things get serious.
Perfect analogy. And speaking of safety, ever heard of object freeze?
Sounds like a spell from a wizard school.
Almost. It locks an object so no one can modify it.
So I can freeze my data and no accidental edits happen?
Exactly. You use object.freezeUser, and now any changes will silently fail in strict mode.
Nice. That's like putting a do not touch sticker on your variables.
Haha, yes. And you can go further with libraries like Immer, which let you write immutable style code easily.
So many tools. Why isn't this taught earlier?
Because mutation seems simple at first, until it breaks something big. Then you learn the hard way,
Well, I'd rather learn the smart way.
and you are. Understanding how references work is the first step. The next is practicing safe data handling in every function, loop, and callback.
So, don't mutate. Duplicate.
Exactly. Unless you're 100% sure. Copy before you change.
Got it. From now on, I'll treat my objects and arrays like precious artifacts.
Spoken like a true dev.
Thanks for explaining it all, James. I feel like I dodged a major bug bullet.
At our next conversation, we can chat about the JSON structure, the difference from an object and where it is used. The main thing, Harry, is not to forget to practice as often as possible. After all, theory without practice is not complete knowledge.
Thank you, James. I always try to consolidate our conversations on the computer. And you are right. When I listen to the material, I only absorb about half of the information, then your explanations and everything becomes even clearer. But only when I sit down to apply the acquired knowledge in practice, then everything finally becomes clear to me.